I'm wondering what value of a would make this function continuous at x equals 0. And I don't know what it is. So let's just kind of get a visual for what's really happening here. Get a scrap piece of paper that I've doodled on a whole bunch. We have this piecewise function where the function is this for everything except 0, every x value except 0, which makes sense. We couldn't plug a 0 in here. Anyway, we'd be dividing by 0. But then, ignore all the other stuff on the scrap paper. But then at 0, we have some y value. So what really happens is this graph looks something like this. And it's switch colors here. Purple axes. There we go. There's your y-axis. There's your x-axis. I haven't drawn it perfectly. There's other little nuances to it. But basically it's this. And I want to know what value I should choose for a to where this function would be continuous. Basically, I'm going to remove this discontinuity by filling in the hole in the appropriate place. So I just need to know where that is. Let me rephrase it. I need to know let's move the paper. Let's move the paper. There we go. I need to know the limit as x approaches 0 of this part of this piecewise function. And when I figure this out, I will know the logical y value, and therefore that would be a. That would be the place where we fill the hole and make this removable discontinuity not a discontinuity anymore. We'd have a continuous function. Okay, so I'm going to figure out what this is. Actually, this looks incredibly familiar. If you remember a few lessons back, we had this particular thing. I'm going to write it over here on the side in green. If we have the limit as x approaches 0 of sine x over x, we just get 1. It's that. So it's this situation, and there was a problem we did within those notes where instead of x and x, we had like 3x and 3x or 4x and 4x. I forget what it was. But basically, as long as they are the same thing, then we're still going to get 1, right? So let's make them the same thing. You can do that? Of course I can. So can you. The limit as x approaches 0 for sine of 3x over 3x. Well, now I have messed up unless I fix it a little bit. This is not a 3x, it's a 12x, but I just want it to look like a 3x, so we'll put a 4 right here. So 4 times 3 gives me that. So using the properties of limits, and this is a lot of stuff that can happen in your head, what we really have is this 4 down here in the denominator, that 1/4. We're going to factor out 1/4. We have 1/4 limit x approaches 0 of sine of 3x over 3x. Well, at this point, I know what this part is. I know that all this stuff right here is equal to 1 because it is, because we've learned that already, and the 3 doesn't change that aspect of it. So we really just have 1/4 times 1, which of course is 1/4, and that is the logical y value that this would be at 0 if it existed, but it doesn't. But that is what would fill in that hole. So there's our a value. All right, let's figure out the b value that would make this function continuous at x equals 1. And if this function is going to be continuous at x equals 1, then this equals this where x is 1. Okay, let me say that again. When we have a piecewise function, we're going to have a function that does like that. Or perhaps it does like that. We want it to do this. We want it to meet. We're going to get that thing to meet at 1 by saying, well, you know what? B squared minus x equals 4 over x minus b at x equals 1. That way, if I graphed it, these two pieces of the piecewise function would meet, and what would be an open circle on one piece becomes a closed circle on the other, and we have continuity. The limit exists, the function is defined, and the limit equals the value of the function. So we're going to plug in a 1 for x. So we have b squared minus 1 equals 4 over 1 minus b, and then we solve it. And it's really going to be, it's going to look complicated, but it's going to get really simple really fast, actually. If you're trying to solve this and you're like, I have no idea what to do, well, you have a couple options. You could cross multiply, which I am going to do, and that might be a little more trouble than it's worth. Or you could jump to strategy number 2, which I'm going to have to do eventually anyway. But I feel like cross multiplying, so let's do it. So we'll put that over 1, and we'll have b squared minus 1 times 1 minus b and that is equal to 4. And then if you're like, well, I have no idea how to solve this at this point, don't worry, nobody does. Well, it's rare that we could solve something like this by hand. If you were to multiply this out, you'd have a cubic, you have to bring your 4 over, and then you'd refactor, and not all cubics factor in a nice, clean way. So here's what's about to happen. We're going to use a really cool strategy where we use a calculator, and that is okay on problems that would not be solvable by hand. And we will type this function in, using x's instead of b's, as y1, and we're going to type this one in as y2. And we're going to see where they meet, and that'll be the answer. It's that easy. So b squared minus 1, but again, we're using x's for the sake of graphing, and then 1 minus b, excuse me, is equal to 4. And we're going to graph it. Let's just go with a standard window first. So zoom standard is number 6, and we'll see the first function, which is cubic, and we'll see the second function, which is a constant. We could graph 4, that wouldn't be hard. It's the other one that would be a little trickier. And we will find out where they meet. So second in calc, and we can find the point of intersection. All right, at this point it's asking us what's the first curve, what's the second curve. Well, the first curve is this cubic, press enter. Second curve is that, and then guess. Usually we just need to be near it. If there's more than one point of intersection, it's more beneficial if you're closer to it. This is the only point of intersection, so let's just press enter. When it asks you to guess, it's just wanting a good starting point based on the way it computes this. So, final answer is b equals, and we will use 3 decimal places, it's this x value right here, negative 1.594. Okay. Now I want to know what value of k would make this function continuous at x equals negative 2. Well, let's do that as well. Let's find where x squared equals kx plus 10. And that will happen where x is negative 2, because if this function is broken, it's going to be broken at negative 2. That's the nature of this piecewise function. And similarly here, if this function was broken, it would be broken at 1. Now, we would have a discontinuity here at b as well, but anyway. So what we're going to do is take a negative 2, plug it in for x. So we have k times negative 2 squared equals k times negative 2 plus 10. Let's simplify a little bit. We have 4k equals negative 2k plus 10. And at this point, we're just solving a regular equation. So 6x equals 10. We divide by 6. We have 10 over 6, which is 5/3. And that, my friends, is all.